Is it chicken?
Yeah. Only until they get it from smugglers. Guess not you guys.
Just imagine that clip for a second. An ingredient as popular and common as chicken has become so rare that it has to be bought from smugglers. That might seem very extreme, and this clip from HBO's new show, The Last of Us, is quite extreme. But our next guest is going to talk about how thousands of ingredients that our ancestors relied on for years have actually become just as rare, if not rarer, than the chicken you see in that clip there. Many of those ingredients actually would be unrecognizable to most of you in the audience today. It's a scary thought, no? Just imagine that. Chicken. So rare that it has to be bought by smugglers. That thousands of the plants that make up the ecosystem we all call home have been slowly disappearing, protected by a handful of very special producers around the world. I promise you that the next conversation we're going to have will be one of the most important discussions we have on stage today, told by one of the most thoughtful and curious food storytellers we have in the business. Please welcome from England the producer and presenter of the BBC's food programme and author of Eating to Extinction, Dan Saladino.
Hello, everyone. I feel like a bad guest at a dinner party because I didn't bring a bottle. No, nobody warned me. Thank you, Ryan. I want to talk a bit about heritage, inheritance, skills, knowledge, and extinctions. Perhaps most importantly, storytelling as well, which is what I do. So I've written a book called Eating to Extinction. It's been translated into a few different languages. But it's a book that is full of stories. I'm not a chef, I'm not a scientist or an academic. I make radio programs. That's a broadcasting house in London, where in 1979 a journalist who'd been a news correspondent had become concerned in the 1970s about what was happening with British food traditions. So he traveled across Britain with a camera crew, and they recorded foods as a last chance to see before they disappeared. And the 1970s, in the story I'm telling, is a crucial decade. He then, in 1979, convinced the BBC that what the audience needed was a radio program, a weekly radio program that talked about the economics, politics, science, culture of food. And they gave him 6 weeks to make a radio program. And after 6 weeks, he said, we've told these wonderful stories about food. The audience have enjoyed them and given us some very good feedback. And he said, can we make some more? And they said, Derek, because his name's Derek Cooper, Derek, you've had 6 weeks, and it's only food. What more is there to say? And more than 40 years on, the program continues, and the agenda continues. But very quickly into my time at the food program, which starts in 2007, I traveled to a place where my father came from, Sicily, and I went there to make a program about citrus, and what I thought would be a celebratory program about a fruit that had shaped the landscape over 1,000 years. But I arrived, and there were farmers telling me that they were going to leave the fruit on the trees the following year. It was the last harvest. And then I realized that this culture, this landscape, this identity, and flavors that had shaped much of Sicilian identity was disappearing because the economics no longer added up and they were leaving the land. And somebody on that visit told me, well, these fruits, these blood oranges, for example, Tarocco, Moro, very particular varieties needed to be added to something called the Ark of Taste. And I had no idea what the Ark of Taste was. And then I learnt that it was the Noah's Ark of Taste. So it was a refuge, a place where people could tell their story of what was disappearing in their particular part of the world. And I made a radio series, which you can find online. So this is the Ark of Taste, the world's most endangered foods, a radio series. And I found 50 different foods from around the world. And I told the story of that food, why they had come into existence, why some people around the world were concerned that they were disappearing. And I also tried to answer the question, why should we care? And as you can see, there's one from the Basque Country here. But yeah, 50 different stories. And the Ark of Taste is an online catalogue. So it contains more than 5,000 endangered foods from 130 different countries. And in 2018, I had the opportunity to write a book, and there was no other subject that I cared about as much as these endangered food stories that I'd encountered. And so I embarked on not only researching these stories, but also traveling to different parts of the world to find the people who were saving the world's most endangered foods, but also knowledge and culture. For example, it took me to Tanzania, to East Africa, near Lake Eyasi, where some of the last hunter-gatherers in Africa can be found. So we think the Hadza tribe have lived around Lake Eyasi for more than 50,000 years, at least. And there's a population of around 1,000, but only 200 are now practicing no form of agriculture. They are hunter-gatherers. And the wonderful story that I witnessed and included in Eating to Extinction is a relationship between humans and another species, a bird. So I followed the hunter-gatherers into the savannah, and they would whistle. And the whistle, a particular pattern, would attract a bird, scientific name indicator, and the bird would lead the hunter-gatherer to a tree where there was a bee's nest and honey. And the reason why this relationship evolved, and we think it could be 700,000 years old, to the time when humans started to really be able to control and use fire and smoke. The human wants the honey, and the honey actually is the Hadza's #1 favorite food. But it will take hours to explore baobab trees and to find and locate these nests. The bird also wants the honey. It wants some of the wax, it wants some of the larvae, and it can save the hunter-gatherer a huge amount of time. So it will lead the hunter-gatherer to the honey. The hunter-gatherer will climb up, extract the honey, leave something behind for the bird. But on this trip, just on the outskirts of where the hunter-gatherers are, these 200 hunter-gatherers who have these skills, knowledge, our collective inheritance as human beings, really, as Homo sapiens. Somebody had built a hut, and there were some of the, I guess, big brands of some of the sugary soda drinks that had been brought there from the next big city, which was eight hours away. And so a new source of sugar and sweetness and energy was entering the world of the Hadza. And it's possible that in our lifetimes that this ancient practice, this story that's so deep in human history, could completely disappear. So I felt a sense of urgency to collect as many stories as possible of these disappearing foods. Not just foods, but as I mentioned, the knowledge and the skills. And it took me to another big picture as well of the global food system. and that how in the space of less than a century, in a way, there had been so much homogenization of how we live, how we farm, and how we eat. So, for example, as I explain here, one of the building blocks of our food system, seeds, is now in the hands of just 4 corporations trading the majority of the seeds produced in the world today. Half the world's cheesemakers are using the enzymes and the starter cultures that are produced in a laboratory just on the outskirts of Copenhagen. In terms of genetic erosion, so when it comes to the plants and animals that feed the world, from a picture of huge diversity, we've shrunk down the genetics to the point where, a breed of pig, the large white, now populates most of the world's pork-producing systems. And most famously, perhaps, although there are 1,500 different varieties of banana we produce on a global scale and trade, just one, the Cavendish, which some of you might be aware is now under attack from a fungal disease, Panama disease, or TR4, because of the genetic uniformity of this cloned plant. So we've created more uniformity in the food system, and it's increasingly fragile. I also wanted to understand, how did diversity come into existence in our food and foods around the world? And it touches on some of the themes in the previous conversation about early waves of globalization. So if you just take one example of one of the crops that feed the world, so there are 6,000 edible plants in the world. We now depend mostly on just 9, 3 of which, wheat, rice, and maize, provide the world with more than 50% of its calories. But I think the most important information to take away from those numbers is that the crops that feed the world had a huge amount of diversity, and those crops now are genetically uniform again. So from thousands of different types of rice and maize, we now have just a handful. So in the Fertile Crescent, southeastern Turkey, parts of Iran, Syria, the hunter-gatherers who 10, 12,000 years ago were interacting with wild grasses started the domestication process that would unfold over thousands of years and huge geographical space to produce the crops that we now depend on today. And from the Fertile Crescent, there was the Neolithic package, which included wheat, barley, chickpeas, lentils, a few other plants as well as the domestication of some of the animals that we depend on as well. So cattle, for example, sheep, goats. And these farmers, these early farmers, spread out in all directions, taking with them their seeds. Those seeds and those plants, the crops, would adapt to specific environmental conditions, how much water there was, what kind of soil, the altitude, and also cultural preferences. So we end up with huge amounts of diversity of these crops in these local and regional food systems. I traveled to Turkey, eastern Turkey, where the story of wheat begins, and when wild grasses came together and were selected by the early farmers. And there was one type called kavalja, which is a type of emmer. And there was just one pocket of a community and farmers who were still growing emmer, and we think it's been in continuous cultivation in this one part of the world for 8,000 years. Well, there are reasons why it survived, is because very little else will grow there because of the altitude, and the humidity would mean that fungal diseases would wipe out modern wheats. So the community understood the value of it, but it was ingrained, no pun intended, in their identity and their culture. What I The stories I tell in my book are not new. The concerns over the disappearance of food diversity is not new. So in the 1920s, a Russian botanist, Nikolai Vavilov, started to travel the world and across 5 continents in order to collect the seeds of the plants, of the crops that were disappearing, because he was convinced that the future of humanity depended on saving that diversity before it disappeared. Including in his travels was San Sebastian, and then he traveled west to Asturias, which is still a place of particular interest for crop researchers and archaeobotanists. Vavilov believed that mountainous areas were some of the most important parts of the world because this is where diversity could be found. The conditions of living, of humans settling around mountains meant that there was an extremely diverse and adaptable food system, and that's where he focused his attention. Vavilov fell out of favor with Stalin in the late 1930s after assembling a vast collection of seeds based in St. Petersburg in Europe. And when St. Petersburg was surrounded by the Nazis during the war, there were people who were so convinced in the ideas of Vavilov that the future of the world depended on these seeds. They protected the seeds, and many lost their lives. 9 people in the St. Petersburg seed collection starved to death as they were surrounded, besieged in the city, when they could have eaten some of the collection, the rice and the seeds. They sacrificed themselves in the belief that these seeds were globally important. Diversity was also the main asset of another botanist, Norman Borlaug, who started a project in Mexico in the 1940s to find ways in which he could help poor farmers who were struggling with how much wheat they could grow, but also crop diseases that were causing loss of crops in fields. And so he took different types of wheat from around the world, including one from Japan, a dwarf wheat, and bred a new type of wheat that was so successful it began to travel the world in the 1960s, from Mexico to India, Pakistan, Afghanistan, and then by the 1970s it was starting to find its way into breeding programs in Europe, and by the 1980s a lot of Europe was now based around this new type of wheat that Norman Borlaug had developed. It was a mission to feed the world and prevent famine, and at the same time it was based on the idea of these new crop genetics that created so much uniformity in the world that there were people already in the 1970s saying this could become a real problem for the future of humanity. Jack Harlan, an American botanist in 1972, wrote a scientific paper called The Genetics of Disaster. And as you can see, he says these resources, and by that he means seed diversity, food diversity, stand between us and catastrophic starvation on a scale we cannot imagine. His argument actually was then accepted, and so in the 1970s, you start to have these big centers of seed collection around the world. This is CIAT in Colombia, so I was there recently. This is a storage room with probably the biggest collection of beans in the world, collected from the Americas. This is cassava, and these crops are extremely high maintenance to ensure that they are still viable, that you can grow them again. So each one of these tiny tubes now containing a young cassava plant from, I think, about 80 different countries this collection is sourced from. They each have to be almost refreshed every few years. And all the beans inside this collection, they all need to be individually inspected to make sure that they are viable. But the problem is, this mission, which was carried out with great urgency, was focused on the genetics. And so seeds were taken out of locations, out of cultures, farming cultures and food cultures, and placed in a seed bank. And they have been used by crop breeders because whenever there is a big outbreak of a disease in a crop, for example, they go to these collections for the solution, for the genetics that will create resilience, crop resistance. And increasingly, crop breeders are now looking at things like drought tolerance or other issues linked to climate. And there are stories that don't make the headlines, but they should. So unfolding at the moment are diseases such as blast and fusarium, head blight. These are actually destroying the livelihoods of farmers and also destroying crops on a huge scale. And as a backup, because these seed collections depend on the governments and funding organizations in different parts of the world, because they are fragile in themselves, the Norwegian government helped to fund a tunnel being dug down into the Arctic Circle as the Doomsday Vault, the backup for all of the world's seed supply. And this is Svalbard. And, for example, the Vavilov Institute in 2010, as just one example, for a housing development, the fruit collection was almost lost. So the future of the world's food and these genetic resources are extremely vulnerable. Which is why it's important that there are these heroes around the world who dedicate their lives to saving these endangered foods and this food diversity. This is a farmer in southern Germany called Wald Mamel. He is part of a community in which that Neolithic package that I mentioned, which included lentils, as those foods traveled across Europe thousands of years ago, there was one particular type of lentil that found its way into southern Germany, into this high altitude area, and it was perfectly adapted over generations to the conditions, and also in a culinary sense as well. This became a really important food. But in the 1960s, it went extinct. Canada became the #1 producer of lentils, and they became very cheap exports. And also Germany was industrializing, and there was a lot of movement from rural areas. Wald Mamel believed this lentil was part of his inheritance, and he wanted to bring it back. So he contacted all of these seed banks around the world with no luck. It was also part of a farming system. So the lentils could help fertilize the soil to grow other foods as well. So he believed that was important for the future. He was so desperate that he actually decided with a group of other farmers to travel to Russia, to go to the Vavilov Institute and see if they had something that was close to or resembled the lentil. He hoped somebody had visited the community in the 1930s, 40s perhaps, and had collected the lentil and saved it. But there was no evidence of that. But when he arrived in St. Petersburg, he realized actually somebody had written the label of the collection incorrectly. There was a spelling mistake, and they actually did have this lentil that had been collected from southern Germany. And I think the next photo is one of my favorite photos because it shows the connection, the importance of a food to identity and culture. So he arrives in St. Petersburg and he finds his lentil and he's reunited with this food. And it's important because his story inspired so many other farmers across Europe to look at what had gone before, what had been grown in the past. And people started to research. So, for example, there were pulses, there were beans that were being grown in Britain during the Iron Age. Some farmers brought that back as well, also in Sweden. And they've set up businesses who are bringing back, reviving this lost diversity. And it's more, and I think this is the important thing. So having a seed in a seed bank, that's protecting the genetic diversity of the world's food. But it's become disconnected from so much. The reason why I'm showing you the photo of a physicist based in the US is because he thinks about systems and networks and the complexity of things in nature, but also man-made systems as well. And he includes in this agriculture. And we are just beginning to glimpse how complex some of the world's most traditional food and farming systems have been. Whether that's the milpa system in Mexico, for example, or the interaction between a variety of rice in Asia and the soil microbiome that exists. Science is revealing to us how complex these food systems in history are, have been, and could be in the future if we apply more science and research and understanding how they can be applied in the modern world in a modern context. This is also important for our health because as well as understanding the complexity of agricultural systems, we're beginning to understand the complexity of our own personal relationship with food and nutrition. So, for example, Tolland man, who was excavated in the 1950s in northern Denmark, a body that was more than 2,000 years old, when they looked, because it was so perfectly preserved inside a bog, and the moisture of the bog, they could tell that there were the seeds of 40 different plants inside his stomach. So the Hadza, who I showed you at the beginning, have a potential menu through the seasons of 800 different plant and animal species. I mentioned that there are 6,000 edible plants around the world. Tolland man with 40 seeds in his stomach. And we now understand that the relationship with food and nutrition involves more than just calories and the different food groups such as carbohydrate, protein, etc. We know that within all of us now is this organ, effectively called the gut microbiome, the trillions of microbes that we all host that interact with our food. And we know for sure now, because of the research, the more diverse our diets, the more diverse our gut microbiomes. The more diverse our gut microbiomes, the more beneficial that is for our physical and mental health. So complexity is one of the things that has become endangered in the food system, replaced by uniformity. One thing I'm now researching is ways in which you can find the rare and surviving complex systems in the world. The UN, FAO, the Food and Agricultural Organization, 20 years ago launched a project to try and find some of these complex systems and protect them. So these are the GIAS, globally important agricultural heritage systems. There are now around 70 around the world. There aren't many in Europe, but what I find is fascinating is that Spain has the highest number, I think, of GIAS sites in Europe, including, as we've heard, the salt pans is one of them, and the interaction between humans, the landscape, and also the biodiversity that exists in the wider area. Another one is based around the ancient olive trees as well. And I think increasingly researchers are beginning to take a look at what has survived there, the culture, the interaction that takes place on an agricultural level, but also a cultural level as well. Because these are examples in which humans have had a more harmonious relationship with nature and finding ways of producing food that don't involve, again, the removal of complexity and the destruction of habitat. And just finally, I visited a place called NIAB. This is in Cambridge. NIAB was founded 100 years ago. It's the National Institute of Agricultural Botany. This is part of the mainstream farming system. So what these crop researchers do is produce the wheats for farmers, not just in the UK, but also Europe as well. So you might have noticed that in Svalbard, there are more than 200,000 accessions, samples of wheat collected around the world. If you are a farmer in Europe growing wheat, you'll probably be given a legally recommended list of around 10, and these will all be genetically uniform. What the scientists are now doing is they are going back in the evolutionary history of wheat, going back to the wild ancestors, going back to some of the areas in which the very first farmers domesticated the wild grasses. They are finding the wild grasses that actually created the wheats and taking those materials and creating a new generation of more diverse wheats. I think we should be positive and optimistic that after a century in which science, or the application of science and technology, resulted in the disappearance of uniformity, with the Green Revolution of the 1960s and so on, science is now giving us more and more reasons to protect diversity, save endangered foods, protect these complex food and farming systems, of which just a few have survived around the world. So again, like a seed bank, this is only part of the story. The genetics. I think what's really important is telling the story as well of how we got here, that's why I make the radio programs I make, that's why I wrote the book, Eating to Extinction, because we all need to know this story. I believe this should be taught in schools. Where did our food come from? What are the events that have changed our food system over centuries? And this is why I also believe, because very few of us will meet a scientist or a botanist, a seed saver, it's very hard for so many of us to hear this story, which is why I think journalism, writing is important. But also, this is why I believe chefs and restaurants are important, because I think in the 20 years I've been a food journalist and researching and writing, and particularly in Eating to Extinction, one of the few places of interaction in which we get to meet people who understand the ingredients that they're working with and that we eat, they are chefs. Chefs, I think, are some of the most important storytellers. People in the hospitality world, I think, are some of the great communicators of these complex issues that arrive on a plate. And so I would really be keen for all of you to leave today or leave the conversation after a couple of days and at least take with you some of the story I've told. And perhaps if you do have the opportunity in the context of a restaurant, or if you get to tell a food story, please try and share some of this story of why food diversity matters and that we need to protect complexity. So thank you very much.